Hey folks, this is Praveen, and today we're gonna see the LeetCode problem trapping rainwater, and this considered to be a hard problem. Um, what the problem statement says here: given an non-negative integer representing an elevation map where the width of each bar is 1, compute how much water it can trap after the raining. So basically this is the diagram given, one example given where these number are the height of these pillars or the column, and the width of each column would be 1 unit. So we'll have to identify when the rain will happen how much water this structure can hold. Um, there is another example given where the height of pillar is 4, 2, 0, 3, 2, 5, and the output is given 4. So let's try to understand this problem visually. Um, so here we can see the input of columns is given like 0, 1, 0, 2, 1, 0, 1, 3, 2, 1 to 1, and I have plotted that in the order it was given. So our structure would be like this, and we'll have to identify when the when the rain happen how much water this structure can hold. We can consider this as the pillars and this place basically, and we'll have to identify how much water it can hold. So we can try to solve this. So we can see like the leftmost and the rightmost part could not hold the water because it will fill the water, it will spill out from the left side, and it will try to fill the water here, it will spill out from the right hand side. Now to solve this, we can see like we can hold water here, we can hold water in this area, and we can hold water here. And how we are deriving it, so we can understand it by this. So here this area we can check which is the like left max pillar from here. So we can say this is the left max pillar from here, and which one is the right max pillar from this position. So it would be this. So, and if we'll see like how much water it can hold, if we'll have these two pillars, so it will hold water till this level, whichever is the minimum of the left max and the right max. And since it does not have any uh, height, the self height, so it can like fill the complete water till this level. Let's try to understand by this another example. We can take this position. So what is the leftmost left max pillar on this? That is 2. What is the right max pillar from this position? That is again 3. So which is the minimum? So minimum is 2 because we can hold it can keep water till this level only, otherwise it will spill out from here. And since it has its own height, we can subtract that from the 2. Why 2? Because this is the maximum water it can hold, up to 2 unit, and since it has some height, so that would not be filled with the water because it is the column height, so it will only fill the 1 unit. So that's how we can actually get the every block capacity, and we can sum up all these filled water, and we can get the final answer. So what would be our formula here? So we'll get the min of left max and the right max. When I say left max, we can check for any particular position what is the maximum left length, and right max would be the what is the maximum right column length, and whichever would be the minimum of that, we'll consider that, and we can reduce the self height from that amount. So that will give us the water capacity of that particular block, and when we'll get it, we can sum that up to get the final answer. So this is the place where it can hold the water. So this would be 1, 2, 3, 4, 5, 6. And how we are calculating it? So first we'll get the left max. How we'll get the left max? So here the self on the first position, it's the left max height is 0. Then we got the 1 height. Then here again it's a 0, but we already had the max as 1. Then here the pillar size is 2, so we'll consider left max as 2 here. Here it's the pillar size is 1, we'll consider 2, so far and so forth, and we'll like get all the left max. Similar, we'll try to calculate the right max. So that's how we can calculate the right max. So here in the same way, we can see what is the maximum right pillar here, height here, that is 1. Here we have two pillars, so that would be maximum height would be 2. Here we have pillar size 1, but since we already know the right most like right pillar height is 2 already is the max one, so we can consider 2, and we can fill this right max array also here. And at the last we can since we already identify the formula, min of left max and the right max, and we'll subtract the current height. So that's how we can calculate the capacity of each block, and we'll sum all these up to get the final answer. So let's try to write the code for this. So since we already know we need to array for the left max and the right max, so let's initialize that. Left max equal to new int, and the size, of course, it would be uh, equal to height length. And similar to this, we'll be having a right max. We Since we're gonna traverse this complete array, we'll be required to pointer on the left pointer and the right pointer. So I'll be having one variable, the pointer of, I must say, L equal to 0, int R equal to um, height dot length minus 1. Here we can have two temp variable, so we can call it as int uh, left high equal to integer dot min value, and I think it should be capital. Similar to that, we can have another temp variable for the right height, and that will also initialize as a min value. Now we have all the required parameters created, or the variable created. Now we can iterate over the loop, iterate over a height array. So how will I iterate it over? So we'll see when our left pointer is less than height dot length, we'll keep running this loop. And what we're gonna do, we're gonna check two things. One is if our left high is less than our height left pointer value. In that case, what we're gonna do, we're gonna assign left high, which is our temporary variable, to the current value of height, and we'll see if our right high is less than height of right pointer, because we are going from like we are calculating for left as well, left max and the right max both. So here in this temporary variable, we're gonna assign our height right, and after this check, we can actually assign our left max of L with the left high value, and right max of R with the right high value. Once this is done, we can move one step from the left pointer and reduce one step from the right pointer and move one step forward from the left. And once this loop is over, we'll be having our individual capacity calculated. Um, Something is wrong because this is the extra one I added. So once our this while loop is done, now we have the left max, right max, and the height array created. Now we'll iterate over our arrays and we'll calculate the capacity. So for that, I can create one int sum. This is basically our total uh, capacity our structure can hold, and I equal to 0, I is less than our height dot length and I plus plus. So we are actually iterating our height array. Now we already know our formula, so that is sum equal to sum plus. This is basically I am summing up for each and every block, and our formula was mat.min. The left max and the right max, whichever is the minimum from both, we'll consider that, and we'll reduce the self height from that, so that is height I. So once this loop is over, we'll actually going to sum up all the individual block and at the last we'll return the sum. So yeah, if I have written this correctly, our code should work. So let me try to run this. Yep, it seems accepted. Now let me try to submit this. Yeah, it seems working. So that's how we can solve the rainwater problem. Now let's talk about the time complexity of this. So that would be, we have two loops. So basically, which is running two times. So 2 on, which will say like on, and the space complexity is again like we are storing the left max and the right max. So it would also be on. So yeah, if you like this video, please like and subscribe to the channel. Thank you.